All right, so let's discuss digital circuits. Digital circuits are circuits that work with one and zeros, so high level and low level. All the computer information is digital. Most of your devices these days are digital, and the voltages are changed into high level voltage and low level voltage, or in other words, they are treated as ones and zeros or bits. So all the digital circuits are made out of different components, in general what we call gates. Uh, Gates are electronic components that take a sequence of one and zeros, and based on the function of the gate, it produces another output sequence of one and zeros. So there are seven different type of gates that are discussed in your tutorial. Let me open the tutorial real quick. So these are seven different type of gates that are briefly discussed over here. You're going to study these gates in detail in digital systems 1 and digital systems 2, and different circuits that are made out of these gates. There are three basic gates, which are NOT gate, AND gate, and OR gate. NOT gate, the output is opposite of input, as you can read. So if input is 1, output will be 0. Input is 0, output will be 1. AND gate can have multiple inputs, and if all of the inputs are 1, then the output will be 1. If any of the input is 0, the output will always be 0. An OR gate, again, it can have multiple inputs, and if all the inputs are 0, then output will be 0. If any of the inputs is 1, then the output will be 1. So it's kind of opposite of AND gate. And then there are advanced gates, which are NAND, NOR, XOR, and XNOR, which are made from combination of different combinations of these basic three gates. And as you can read, NAND is opposite of AND, NOR is opposite of OR, XOR, it has two inputs, and if both inputs are high, if both inputs are opposite, output is high. If both inputs are same, then the output is low. And XNOR is opposite of XOR, that is, if both inputs are same, output is high, and if both inputs are opposite, then the output is low. So how do we create circuits out of these gates? There are a few circuits given in the tutorial that you can see. So what I'm gonna go ahead and create a circuit, show you how you can simulate a circuit with gates, and where you will have to put probes and all those things. So let me go to my capture. Now gates are present in multiple different libraries. In the tutorial, I think I'm using 74LS library. 74 is a series of gates. LS stands for low power short key, which is basically uh, a way that they integrate a specific way that they integrate these gates. Um, there are gates available in 74, 74LS, and multiple other libraries. Eval is another library where the gates are available. Since you are using the newest version of PSpice Lite, which has all the libraries included, you can use 74LS library. It's not going to give you any error when you use it. I think I still have the older version installed on my system, as I discussed in the last video lecture. And let's see, I have 17.2. I'm not sure what is the current version. In any case, when I was working on BJT lecture, if you went over that lecture, you saw that when I was using BJT from bipolar library, it gave me the component error, that it could not locate the component. So I'm assuming if I will use gates from 7.4 ls library, it may still give me the component error because in the older PSpice Lite version, 7.4 ls library was not part of the version. Hence, even though if I included that library, it would still give me an error. And then I had to go to the configuration files, and I will have to manually add the 7.4s library as I showed you in the transfer lecture. So instead of going through all that hassle, I'm just going to use gates from eval library, because eval library was one of the libraries that used to come with the free version before they included all the libraries in the free version. So let's go ahead and build a circuit and simulate it. So I'm going to go ahead and choose eval library. And in the eval library, you can see all these gates, 7403, 7404, and so on and so forth. So let's grab 7404, which is a NOT gate. Let's see, I'm just going to go ahead and put it here. Let's grab 7408, which is an AND gate, 2 inputs. Let me grab, let's say what is 7402, I think it's a NOR gate. So let me grab a NOR gate. And let's see what else. 7485. I forgot 74. What was the number of XOR gate? Let me go check the library. 7486. So let me grab 17486, which is an XOR gate. 7486 right here. So let's say I have 4 gates, and I'm just gonna connect these gates randomly. Let's see, I'm gonna go ahead and connect this here. I'm gonna go ahead and connect this here, and let's say output of this AND gate is coming here, and I'll just keep it as an input. So let's assume this gate 74U4A, which is 7486. Let's say this is my output gate, and then I have 4 inputs, and I'm gonna connect my input signal to these 4 inputs. And let's assume that same input is going in these two. Inputs, input 2 of U2A and input 2 of U3A. So I'm just extending the wires. You don't really have to do that if you don't want to. I'm just extending the wire to put probes and connect the sources over there. All right, what sources do you use in digital circuit? You don't use the regular sources that we have been using so far: DC source, AC source, transient source, square wave, or pulse source. Um, the one that you need to use is in the source STM library, stimulus library, source STM. So let me go to source STM. Let's see, source STM. So let's open this library, and the one that you need is digital stimulus 1. Let's grab digital stimulus 1, dig STM1. Let's put one here, let's put one here, and let's put one here. As you can see, in the digital stimulus, you have a parameter which is called implementation. Implementation means what signal you want to implement with that digital stimulus. So you have to write down the name of that signal. When you define that signal, then you have to write down the name of the signal under implementation. Okay, go ahead and save the circuit. Make sure keep saving your circuit. All right, so the circuit is ready. Again, it's just a random circuit with 4 gates, and I'm gonna create some inputs, 1 and zeros, sequence of 1 and zeros, using these digital stimuli, and then we can check the signal at different points. In this case, I'm just going to check the signal at the input and then check the signal at the output, which is my U4A. I'm assuming that is my output. So how do you define a signal, a digital signal, for the circuit that you are creating using digital gates? You have to right click on the any of the digital stimulus, select, right click, and then go to edit PSpice stimulus. Edit PSpice stimulus. Now make sure you can only open the stimulus editor once per project. So make sure you keep saving this stimulus editor, because if you don't save it and you close it, it's not going to allow you to open it again for that project. And then you will have to copy your circuit, open a new project, paste the circuit in there, and then have to create a new stimulus. So make sure keep saving this stimulus, whatever you define in this. So once you open the stimulus editor, as you can see, this new stimulus window is gonna pop up. Basically, you are defining a signal. A stimulus is a signal, is a digital signal, ones and zeros. So give a name to your signal. I'm just gonna call it my signal A. Now, don't worry about analog, because you're not defining any analog signal. You're defining a digital signal. So we're gonna use two options. We're gonna define either a clock signal or a signal. What is a signal? Well, a signal, the difference between a clock and a signal. Clock will have a specific time period, a specific frequency, so it will be a periodic signal with a time period and a frequency. And the signal that you see over here is going to be a random signal. So you can define any high and low levels without any periodicity, without any sequence. Anytime you want to make it high, anytime you want to make it low. So basically you are defining a signal that ones and zeros are coming in without any specific sequence. So that signal is defined using the signal option. Again, clock is a periodic signal that has a specific time period and frequency, and it's going to repeat itself. And signal is a random signal, random digital signal. So let's define a clock. And you can choose the initial value of the clock, or let's define a clock with, let's just do it. Okay. Now you can choose the initial, once you define a clock, once you set OK, this window is going to open up that you will have to set the clock attributes. Frequency and duty cycle. Frequency, of course, is how many times the periodic clock signal is going to repeat itself in 1 second. The frequency is the repetition per second. Duty cycle means how long it's going to be high in the complete time period. So for example, if it is high, if the time period of the signal is 1 millisecond, and if the signal is high 0.6 millisecond, then the duty cycle is 60%, 0.6 divided by 1 times 100. So how long the signal is high out of the complete time period. Their ratio times 100% is the duty cycle. So let's say the frequency of the signal, let's take 1 kilohertz. Let's start with 1 kilohertz, 1K. Duty cycle 0.5 means half of the time it will be high, half of the time it will be low. So it's going to be a perfect square signal. So let's define the first signal as a perfect square signal. Take the initial value 0. You can either take the initial value 1 or 0. I'll just leave it at 0. And time delay. After how many seconds you want the signal to start? You want the clock signal A to start. I'm just going to leave it at 0. I want to start it as soon as the time will start. So apply, okay. So observe, it created a square wave, perfect square wave. Half of the time it's high, half of the time it's low, and its time period is 1 millisecond, because 1 kilohertz frequency correspond to 1 millisecond time period. 1 over frequency is the time period, remember. So 1 over 1K is 1 millisecond. So it has a period of 1 millisecond and it is repeating itself. Now by default, as you can see, the range of X is 4 millisecond. You can change this range. You can go to plot and access setting, and you can change over here if you want to go from 0 to 4 millisecond or 0 to 10 millisecond or whatever you want to go from. And likewise, you can change the time resolution, that is the step size. So I'm just going to leave it at 4 millisecond right now. But again, you can change that. Make sure to keep saving it. At any time you define a signal here, save it. If you don't save it and if you lose it, then it's going to be a problem. And if you don't save it, your simulation is not going to locate your stimulus. So make sure to save it. Okay, this is my first signal. I'm going to go ahead and define another stimulus. How I'm going to define a new stimulus? Let me go to stimulus, new, and it's going to open up the same window. I'm going to define another signal, B. Let's say it's also my clock signal. And I'm going to choose the frequency, let's say 3.3 kilohertz. I'm going to change the duty cycle to 60%, so 0.6. Let's say initial value I'll choose 1, and the time delay I assume 0.2 millisecond. Oh, what did I do? Oh, I messed up the signal because instead of milli I just chose the signal. Let's go ahead and change it. 3.3K. Hold on. Okay, let me just keep it 0 because it's going too high. 0. Why? Alright, let me change this lower to 1K. Okay. Yeah, 3.3K is just giving you too long of a time period. So let's see if I give 2K. Okay, 2K is okay, and then time delay, let me choose 0.2 millisecond, 0.2 milli. Okay, that's fine. 3.3K is just making the time period to be very large, and hence the time period of A, the repetition of A are becoming too many. So you could see a thick line over there. So let's go ahead and press OK. All right, so I defined another signal B with 2K, with frequency 2K, and duty cycle 60%. So 60% of the time out of the whole cycle it is going to be high, and rest of the time it is going to be low. Initial value is 1 instead of 0, and I kept the time delay to be 0.2 millisecond. So at 0.2 millisecond it is going to start, and before that it's just going to be high. Okay, these are two of my clock signals. So they have a specific periodicity, and they are not random signal. They are periodic signals. And you can define as many stimuli as possible on the same screen. Remember, with every project there will be only one stimulus screen that you can open. So make sure if you want to define 10 signals, you have to define in this screen by adding new stimulus every time. So these are clock signal. Let's go ahead and define a random signal. So let's add a new, and I'm gonna say C is my signal. It's not a clock, it's a signal. And an initial value of 0, that's okay. You can choose initial value of 1 or 0, whichever you want. So right now the whole signal is a 0 signal. The whole signal is a 0 signal. How do you change levels? To change levels, you see this a high level and low level button right here where my mouse is. Press this button and observe that mouse becomes a pencil. So if you take this pencil and put it anywhere on the signal that you want to the signal C that you want to change into random one and zeros, and click it, it's going to change the level at that point. So if I click it here, it's going to change the level. Click it here, it's going to change the level. So you can change the level wherever you want. Again, it's a random signal. There is no periodicity or frequency associated with this signal. Now you cannot go back and change the level. You can go back and put a tag. Let's say you were supposed to do 1 over there, but it is 0. So you can go back and click over there. It's going to put a tag, and if you delete it, if you delete this, it's not doing it. Delete it. It's oh, I'm not deleting. I'm skipping. Sorry. All right. If you delete it, it will change the level at that point. Okay. So make sure if you are supposed to change level and you forgot the level, go back, put a tag. Okay. Okay. It's just showing you the digital illustrator. Okay. Oh, I don't have pencil. That's why. All right. Go ahead and put a tag and then press delete, and it's going to change the level over there. Okay. So once again, you can change the level, but it's not going to show you the level change right away. But you can go back, put a marker, and delete, and then it's going to change the level at that specific point. So I defined a signal which is a random signal. Observe, it's a random signal. It does not have any periodicity. So how do you choose random signal? Again, you choose random signal by going to stimulus, new, and let's say D. Instead of clock, choose signal. Now, in the older versions of PSpice, there were high signal, constant high, and constant low signals in the same library where the ground is. So if you want a signal to be constant high and constant low, you could choose those signals from the same library where the ground is. Now in the recent version, although it is in PSpice, the constant high and constant low, and those signals are discussed in the tutorial, but they did not put them in the same library, although they are present in PSpice. So if you want your signal to be constant high or constant low all the time, the easiest way to do that is just choose a signal and choose the initial value. For example, if you want your signal to be constant high, then all you have to do is to choose 1 and okay, so your signal is now constant high. You don't have to change any level. If you want to keep it constant high, this is constant high. Okay, and likewise, if you want to keep the signal constant low, do the same thing and then choose the initial value to be 0. It's going to create a signal which is constant low, and then you don't really have to change the level. All right. So after defining multiple stimuli here, how are you going to use this stimuli to simulate your circuit? So we're going to go back to the circuit. Where you have implementation, observe that they already put implementation is equal to A because that was the first signal that was defined. You can change this. Let's say I want my signal B for the implementation of DSTM1, digital stimulus 1. So all I have to do is to write down signal B, that is the signal which is this. Whatever name you are putting down over there, it's going to come and it's going to grab that signal from this stimulus editor. Let's say I need my signal D over here, which is my random signal, and let's assume this is my signal A. So now the B signal, what I defined here, and A signal and C signal or D signal, which is high. Sorry, I'm gonna change it because D signal is high, so I'm just gonna use my C signal over here. I want it to go through some variation instead of always high. Okay, so now I have my B signal, C signal, and A signal implemented or assigned to DSTM1, DSTM2, and DSTM3. Those are my inputs, and then I'm going to run the simulation and I'm going to check the output, and you can also check the level at the output of each gate, whatever you want. Let's save it. Let's create a simulation. And since you are defining the stimulus versus time, that means you have to do transient analysis, because versus time your signal is changing ones and zeros, high level and low level. So let's go ahead and choose transient analysis. Your runtime right now, my stimulus time is 4 milliseconds, so I'm going to keep that to my total runtime so it can run the whole stimulus. 4 milli. And I'm just going to start saving data after 0 second. And maximum step size, just keep 0.01 milli. That's okay. 0.1 milli will also work, I guess, but I'll just keep 0.01 milli. Apply. Okay, come on. Okay. All right, let's go ahead and run the simulation. Hopefully, we'll not get any error. Oops. Okay, right here. Oh, there are error. It's gonna give him. It's giving me. Well, I don't understand why it is giving me all these things. Okay. I'll have to figure out why it is giving me all these things, because eval library was part of the free libraries. But anyway, since it is giving me these errors, I'm just gonna take care of these errors. I'm hoping, again, you're not gonna get these errors. So there are two different type of errors it is giving me. The one error it is giving me is model IOSTM used by this is undefined. And the second error type is subscript 7404 used by this is undefined. It's very strange that it is giving me these errors. It should not give me these errors, because as I said, eval library used to be part of free libraries, and I have used eval without any problem. But anyways, it is giving me error. I'm just going to go ahead and take care of these errors. So these errors are pretty much the same as we got in the transistor circuit, that the transistor was undefined. It could not locate the transistor. So what I'm going to do, I'm going to include the libraries where I grabbed these components from, that is the eval library. And this specific error is the input output error. As you can see, IO, input output error. And this error is usually taken care of if you add what's the library, digital IO library, digital input output library. So let's go ahead and include both libraries. If you do get these errors, I'm hoping you're not going to get these errors. If you do get these errors, then you have to add two libraries. The libraries from where you're getting your digital gates and the digital IO library. So let's go ahead and do that. It's really strange I'm getting these errors, because eval library, as I said, was free library and it should not give me that error. So let's go ahead and configuration file. One more thing, observe that my stimulus is here under stimulus. If your stimulus is not located here, you will see all red lines in your simulation, all red lines. Then you have to go back and check this to see if your stimulus is there or not. If it is not there, and that usually happens if you're not saving your stimulus. As you are creating the stimulus, you're not saving them. But if you don't see the stimulus, even if you saved it and if you don't see it, then basically you have to add it manually by browsing to the folder where you are saving your files. So I'm saving my files where I'm saving my file. Let's see. I'm saving my file on. I'll just go to my folder. Teaching Valencia Spring 2019 software app lectures. Okay, and then digital. Okay, so if you do see all red lines in your simulation, and you come here and you see that your stimulus is not here, then you will have to go to the folder where you have saved the project. And then if you have saved the stimulus, then the stimulus will be located over there, like right here. This is my stimulus file. If I expand this and I expand it, no, I can just move it. Okay, if I move it, you can see it is PSpice stimulus file. So again, if you get an error. It's not going to give you error actually. It's just going to show you red lines. That's it. It's not going to show you any up and down, which is usually green, up and down, zeros and ones. So you make sure to add this digital stimulus under the stimulus category. Okay, I already have it, so I'm not going to add it. I'm going to go to library, and then I'm going to add the two folders. You know what? There is usually a file over here which is missing, and I'm assuming since that file is missing, that's the problem that I'm getting there. It's not recognizing the component. Anyways, I'll figure it out later. Right now, let's go to this folder right here, which is tools PSpice library. So let's go to tools PSpice and library, and then I'm gonna add digital IO right here, DIGIO, and add to design, and then I'm gonna go to the same and I'm gonna add eval as well. I may have to just uninstall the PSpice and reinstall the latest version, and it will take care of everything. Alright, I'm gonna add the eval as well. Apply, okay, and keeping my fingers crossed that it's gonna take care of the problem. It's still giving me error. Okay, let's see. File. This is strange. Why it's still giving me undefined of these? I did add the library. Okay, let me go back. I got these from eval, and I did add eval. Let's see. Configuration, library. Yeah, eval lib. I did add it. Now this is strange. Browse. Okay, add to design. Apply. Okay. Still giving me error. Okay. All right. Well, I guess I'll have to take care of it. Let me have a class. Let me go to the class and come back and then take care of it. Let me pause the video. Alright guys, so I'm not really sure what's going on with eval library. For some reason I think it's my PSpice is corrupted or something, and it is not working. But anyways, so what I did, instead of using the gates from eval library, I'm using the gate from 74ls library, the one that I'm using in the tutorial. So same gates, but instead of using from eval library, I'm using them from 74ls library. So now when I use from 74ls library, it does give me error that gates cannot be located. So again, what I did is the same thing I was doing for earlier for the gates that were not located from eval library. So I went to the configuration file, library, and then I added 74ls.lib over here from this folder right here, 74ls.lib. So when I added this, it worked. I have no idea why it's not working for eval if I'm using the gates from eval, but again, it's some sort of misconfiguration going on in my PSpice. Again, hopefully it's not going to happen to you. So I added this, and then I simulated it, and it worked. There is no error that I'm getting right now. So once again, guys, I'm quite confident it's not going to happen to you if you have just installed PSpice. Even if you're working in the open lab, it's most likely it's not going to happen to you. So now how you're going to see the simulation? You're going to go ahead and choose the voltage probe, and what I need you to do for the exercises that you have to do for homework is show the simulation for inputs and output. So you're going to put it at each input. These are your inputs: stimulus 1, stimulus 2, and stimulus 3. And then this is your output right here. So you're going to put probes over there. The probes color will be black. It's not going to change. but that's okay. And when you go over here in the simulation window, now this is different than the stimulus editor. Remember, this is a stimulus editor where you defined all the signal, and this is a simulation window where you're looking at different outputs when you put probes. So this is your simulation. This is the output of stimulus 1, output of stimulus 2, output of stimulus 3, and this is the final output of the XOR gate U48. So this is you will be doing for the two exercises that I will be assigning you, or you will have to do for the last homework. Once again, in the tutorial, there's a high signal and low signal. If you cannot find that, just create your own signal, define it to be all high all the time, or all low all the time, as I defined mine right here, signal T. All right, it's time for me to go to the class. So I'm gonna finish this tutorial. If you have any questions, even after going over the tutorial and going over this video, just email me. And then remember, when you email me anything, make sure to add all the simulation pictures and everything. So if you're getting an error, I can figure out what and why you are getting an error. All right, I'll see you on Tuesday. And remember, it will be the PSpice exam on Tuesday. All right, see you next Tuesday.